Hello students, good morning. Hello everybody. This is another session of arithmetic progression from class 10 mathematics. In the previous session we have learned about how to solve situational problems using the concept of arithmetic progression. Today I am going to show you some different types of question which you can find in the exam papers and in sample papers and other books. So let me read out the question first. The question says, if the sum of p terms of an AP, first p terms of an AP is equals to sum of first q terms, then show that the sum of its first p plus q terms is 0. Let me write down the question. If the sum of first p terms of an AP is equal to its sum of sum of its first q terms then show that the sum of its first p plus q terms is 0. So hope you are getting the meaning of the question. The sum of first p terms is equal to sum of its first q terms. Then we have to we have to prove that sum of its first p plus q terms is 0. Now, using the concept of arithmetic progression and the formula for sum of its n terms, let me solve the problem. So first of all, let me take the first term as a. First term equals to a, common difference equals to d. Okay. Now we know the formula for the sum of n terms Sn is given by the formula Sn equals to n by 2 2a plus n minus 1d. This is the formula to find the sum of n terms of an AP, where n is the number of terms. A, as I have already mentioned, A is the first term and D is the common difference. Okay. Now here it is given in the question sum of its first p terms. So in place of n I have to write p. So this n will be changed, it will be p, and here also. So sum of its p terms, first p terms is p upon 2 bracket 2a plus p minus 1d. Similarly, the sum of its first q terms is equals to q upon 2 bracket 2a plus inside the bracket q minus 1 multiplied with d. Sum of its first p terms is this one and the sum of its first q terms is this one. Now it is given in the question that sum of its first p terms and sum of its first q terms, they are equal. They are equal. That means we can say that SP is equals to SQ. So if this is the case, then let me write in this form according to the question. P by 2 bracket 2a plus p minus 1 multiplied with d is equals to q upon 2, 2a plus q minus 1 upon d. Okay. Now let me simplify the whole thing first, but before that I can cancel these 2 from both sides. So p multiplied with 2a plus p multiplied with d is pd, minus 1 multiplied with d is minus d, equals to here q, then 2a plus q multiplied with d is qd, minus 1 multiplied with d is d. Okay. Now let me simplify again. So the whole thing will become 2ap plus p square d minus pd equals to 2aq plus q square d minus qd. Now let me bring all those things which are in the right hand side to the left hand side and make the RHS 0, that is the right hand side 0. So it will be 2ap minus 2aq. I have to write it in by arranging them properly. So 2ap minus 2aq, then p square d minus this q square d minus pd, and this minus qd will become plus qd in the left hand side. Okay. Now so here I can take 2a common, so it will be p minus q, inside the bracket it will be p minus q, and 2a will be outside. I have taken 2a common, plus here d is taken common, so it will be p square minus q square d, and here I have taken d as common, so it will be p minus q d equals to 0. Understood? Okay. Now p minus q multiplied with ta, here I can use the identity a square minus b square, so it is p square minus q square, so it will be p plus q multiplied with p minus q. So p plus q multiplied with p minus q, and then d, and here also p minus q d equals to 0. Now I can take p minus q common from all the terms. So p minus q, 2a will come here, plus p minus q is already taken out, so it will be p plus q multiplied with d, and here also p minus q is taken common, so only d will be there. So we can say p minus q 2a plus, now see here from these two terms I can take d as common. So if I am taking d as common, then inside the bracket it will be p plus q minus 1 multiplied with d equals to 0. Okay. Now we have got two factors, either p minus q equals to 0 or 2a plus p plus q minus 1 multiplied with d equals to 0. These are the two factors. So either I can take the first part as 0 or the second part as 0. But it is also given in the question that p is not equals to q. Okay. Actually it was mentioned in the question that the p and q are not equal. P not equals to q. So here, since I have got two factors, either p minus q equals to 0, which implies p equals to q, but it is given in the question, but we cannot take P equals to Q as per question. Therefore, we cannot take P minus Q equals to 0. Is not equals to 0. So we have to take the other factor as 0. The first factor cannot be taken as 0. So the other factor is 0. Therefore, we have to state 2a plus P plus Q minus 1 multiplied with D equals to 0. So we have got one relation here. This is equation number 1. Now we have to check the sum of P plus Q terms. So let me use the formula again to find the sum of P plus Q terms. So SP plus Q is equals to, in place of n, the formula for Sn is n by 2, 2a plus n minus 1d. So in place of n, it is P plus Q. So here it will be P plus Q by 2. Then inside the bracket 2a plus, again in place of n it is P plus Q. So P plus Q minus 1 multiplied with D. P plus Q. Now see the whole thing. 2a plus P plus Q minus 1 multiplied with D. What is the value of this one? The whole thing, it is actually equals to, see this equation number 1, the whole thing is equals to 0. That is 2a plus P plus Q minus 1 multiplied with D is equals to 0. So in this place we can write 0. So it will be multiplied with 0. Therefore our answer is also 0. And that is what we have to prove. We have to prove that sum of P plus Q terms is 0, and we have got it. Okay. So this is proved. So in this way, these type of sums, what we have to do, first of all, we have to use the concept, we have to use the formula, write down equations if the equations are there as I have got it. Then use that equation in the other part of the question to solve your answer and to prove your answer. Okay. Now let me discuss one more question of the same type. Okay. So here is the next question. The question is, if the sum of first n, 2n and 3n terms of an APB S1, S2 and S3 respectively, then prove that S3 is equals to 3 times S2 minus S1. Okay. Means the sum of first n terms is S1, the sum of first 2n terms is S2, and the sum of first 3n terms is S3. So let me write it here. Sn is equals to S1, S2n, sum of first 2n terms is S2, and S3n is equals to S3. We have to prove that S3 is 3 times the difference between the sum of 2n terms and 3n terms. First 2n terms and first n terms. Now in place of Sn, let me use the formula. Sn equals to n upon 2, 2a plus n minus 1 multiplied with D. This is equals to S1. And here now it is 2n term, sum of first 2n term. So this will be 2n upon 2, then 2a plus, inside the bracket it will be 2n minus 1 multiplied with D. This is S2, and S3n means 3n upon 2 bracket 2a plus 3n minus 1 multiplied with d, and this is equals to S3. So the question given is we have to prove S3 equals to 3 bracket S2 minus S1. So let me start with the right hand side, this one. Okay, so RHS, okay, let me write down the RHS this side because it will be long enough. So RHS equals to RHS 3 S2 minus S1. Let me replace the values. 3, what is S2? S2 is 2n by 2 bracket 2a plus, inside the bracket 2n minus 1 multiplied with d, okay, minus S1. S1 is n by 2 2a plus n minus 1 multiplied with d. Okay, just check it. This is S2, 2n by 2 bracket 2a plus 2n minus 1d, and this is S1, n by 2 2a plus n minus 1 multiplied with d. Okay, now let me take n by 2 common and write it outside the bracket, n upon 2 from both sides. So it will be 3n by 2. Here what is left? I have taken 2n common, n upon 2 common, so 2 will be left. Now let me simplify this inside the second bracket. So it will be 2a plus 2nd minus d, and here since I have taken n by 2 common, so only this part will remain inside the bracket. So it will be 2a plus nd minus d, second bracket closed, third bracket closed. So actually I am finding this right hand side, so there will be equals to sign. So 3n by 2. Now I have to multiply the whole thing with 2, so it will be 4a, 2 multiplied with 2a is 4a, plus 2 multiplied with 2nd is 4nd, 2 multiplied with minus d is minus 2d. Similarly here I am opening the bracket, so it will be minus 2a, minus of nd is minus nd, and minus of minus d will be plus d. So 3n 2, here it will be 4a multiplied minus 2a is 2a, 4nd minus nd is 3nd, and minus 2d plus d is plus d, sorry, minus d. Okay, just I have taken the RHS, that is right hand side, and replaced their values, and ultimately I have got this value. Okay, now see here, this is 3n upon 2. Now inside the bracket it is 2a plus, I can take d as common from both these terms. So if I am taking d as common, d, then it will be 3n, and this will, there will be minus 1, so it will be 3n minus 1. Okay, so what I have got, 3n upon 2 bracket 2a plus 3n minus 1 d. Now remember what we have got the value of S3. S3 was the sum of first 3n terms. So S3 was 3n upon 2, 2a plus 3n minus 1 multiplied with d. This was S3. Okay. and check this value. This is same, both are same thing, means in other word I can say that this is S3. So I have started with the right hand side, 3 multiplied with S2 minus S1, and finally I have reached S3. So our question, this was the question, to prove that S3 is equals to 3 bracket S2 minus S1 is proved. This is equals to LHS. Therefore S3 is equals to 3 S2 minus S1 is proved. Okay, hope you have understood. So this was the question, and here is the proof we have got. Therefore, using the concept of the sum of n terms of an AP, we can easily solve these type of problems. Hope you have understood the whole thing. Okay, so that's all for today. We have solved so many problems by now. So I shall try to solve few more problems in the next class, and till then have a good day. Bye.